we're going to discuss how to use a theory-based approach when we have quantitative data. So if you're doing a hypothesis test related to mu and you have a sample mean x bar, then we know you could use a simulation in order to help you create a distribution of sample statistics. It turns out if you meet certain validity conditions, you could use a theoretical mathematical approach to that instead. So as it reads here, when you have a sample of quantitative data that is roughly normally distributed, so it's a mound-shaped like a bell curve, or if your sample size is 20 or more, that meets the validity conditions and you'll be allowed to use a theoretical t-distribution to model that distribution of sample statistics. So when you do have that t-distribution, the center of it is going to be mu, the population parameter, just like it was when we used a simulation-based approach. And the standard error, that is the standard deviation of the null distribution, is found using sigma divided by square root of n. Recall that sigma is the standard deviation of the entire population. However, it's very, very, very rare that we would actually have a standard deviation for the entire population. So instead, we do often find ourselves estimating that standard error using S divided by square root of n. And remember, S is the standard deviation from your sample. So again, we can use this theory-based approach when we meet the validity conditions. And if we do meet those validity conditions, you're going to find that our theory-based approach has the same sorts of conclusions that we would have gotten from the simulation-based approach.